Good morning students. This is the 14th part of circles. Today I am going to explain how to find pole of a line with respect to a circle in general form, or if a circle is given in general form. In last part we discussed how to find the pole of a line when a circle is in a basic form. Okay. After that I will explain what is meant by conjugate points, conjugate lines and problems based on all these concepts. So students, this is another important theorem and difficult. So you should remember this result. So the pole of Lx plus My plus N is equal to 0 with respect to S equal to 0 is Px1 y1, Px1 comma y1. Then x1 plus g by L equal to y1 plus f by m equal to r square by Lg plus mf minus n. By using the result you can find x1 and y1. That is become the pole of this with respect to circle S equal 0. Here S stand for general circle, not basic circle. Okay. Now I want to prove this. Proof. Okay. Circle is given. This is the Lx plus My plus N equal to 0. This point is taken as x1 comma y1. This is S is equal to 0. Now directly you know how to find the polar of P. Polar of P. Polar of Px1 y1 with respect to S equal to 0 is S1 equal to 0 only. Already discussed. That is xx1 plus y1 plus g times of x plus x1 plus f times of y plus y1 plus c equal to 0. This is the polar. Already polar is given as Lx plus My plus N equal to 0. These two are identical lines. But again I want to convert this in the form of ax plus by plus c equal to 0. So x1 plus g of x plus y1 plus f of y. Okay, plus gx1 plus fy1 plus c equal to 0. So what happened Nana? This is the polar of P. But pole of P is given by Lx plus My plus N equal to 0. What is the meaning of these? These two are identical lines. Therefore, 1 and 2 are identical lines. Means what happened here? L by x1 plus g by L is equal to y1 plus f by m equal to gx1 plus fy1 plus c by n. So this is important result. Okay, by using this result only you want to find x1 value and y1 value, or you want to show that this happens. See here, x1 plus g by L, okay, equal to y1 plus f by m, okay. So equal to something is given, L square by Lg plus mf minus n. But what you got here? gx1 plus fi1 plus c by n. Now it is enough to prove that this is nothing but this. Let x1 plus g by L equal to y1 plus f by m equal to gx1 plus fi1 plus c by n. Let it be lambda. Okay, Ranana. Actually, in the result, instead of gx1 plus fi1 plus, you have r square. R square means g square plus f square minus c. You want g squares and f square. G square, f square not there. So observe here. So this is taken as lambda. No. What I am doing here? Just I am multiplying and dividing with g here to get the g square. So this just multiplying, dividing with f. Nothing happened. Okay. Then what happened on this one? Gx1 plus g square by gl equal to fy1 plus f square by mf equal to gx1 plus fi1 plus c by n equal to some lambda. Note, this result we can obtain from ratio and proportion. A by b equal to c by d, then the result is equal to a plus c by b plus d, or a minus c by b minus d. For example, a by b equal to c by d equal to e by f, the result also equal to a plus c plus f by b plus d plus f, already proved in ratio and proportions, are also equal to a plus c minus e by b plus d minus f. So I can write a plus c minus e by b plus d minus f. You can prove, that is not big problem. Take a by b equal to c by d equal to e by f equal to some k. Find a value, c value, e value, substitute here. You get, again you get a by b only. Okay. So I am applying this here. So I can say this is this becomes now this. I am applying this rule for here. Gx plus g square plus fi1 plus f square minus gx1 minus fi1 minus c by, okay, gl plus mf, yeah, plus minus n is nothing but lambda. Using this rule now. Okay. So here gx1 get cancelled, fi1 might get cancelled. So what is the left nana? G square plus f square minus c by gl plus mf minus l is equal to lambda. This is nothing but r square. So that is lambda equal to r square by gl plus mf minus n. This one actually you want. So instead of this, what you can write nana? So this is also lambda only, this is lambda only, this is lambda only. Okay, all three are equal to lambda only, no? So this may be equal to lambda, this may be equal to lambda, this may be equal to lambda. Now instead of this I can write this. So what happened? x1 plus g by l equal to y1 plus f by m equal to r square by gl plus mf minus n. Okay students, we got lambda as r square by gl plus mf minus n. So I want to substitute here, or instead of this I can write this. Final result, x1 plus g by l equal to y1 plus f by m. So instead of this I can write lambda, means this, r square by gl plus mf minus n. So by using this result you can find the whole. Equating this with this, you will get x1 as subject. Equating this with this, you can make y1 as subject. From there, you get the px1, y1. Nana, important. So you should remember this. So here we have two different types of situations. For example, x square plus y square equal to r square. Lx plus my plus n equal to 0 is polar. Then how to find pole? We have the formula minus lr square by, okay, comma minus mr square by n. By using this formula you can find the pole. Okay, this is for basic circle. So this formula is for general circle. Okay, how to remember? That is important thing. Here x square plus y square plus 2gx plus 2fi plus c equal to 0. The line is lx plus my plus n equal to 0. x1 required plus g by l. x1 plus g by l equal to y1 plus f by m equal to r square by gl plus fm minus n. In this way you can remember. Okay students, here one example problem is given. Find the pole of x plus y plus 2 equal to 0 with respect to this circle. This is not a basic circle, general circle. So you want to use second result. So first of all I want to find what is g. G equal to minus 2, f equal to 3, c is equal to minus 12. R I want radius, or radius root over g square 4 plus 9 plus 12, I think 13, okay, 5. Now I want to use formula x1 plus g by l equal to y1 plus f by m equal to r square by gl plus fm minus n. Substitutions. x1 plus g means what nana? Minus 2. L means coefficient of x1. equal to y1, f means here 3 by m means x1 equal L r square means r is this r square means 25 by GL G minus 2 L means 1 minus 2 plus FM F means 3 M means 1 3 minus N stands for 2 minus 2 here. So finally what happened here? X minus 2 equal to y plus 3 equal to this is minus 25 or x is equal to minus 23 and y equal to minus 28, therefore pole equal to minus 23 comma minus 28. Okay students, important theorem here or important result. So important note for you people, 12th, 13th, 14th, 15th, these 4 parts are important for you people. So in these 4 parts containing so many theorems and so many results. So these 4 parts doesn't containing any problems in few problems only, but these 4 parts are important for you people because these 4 parts containing a lot of concepts, okay, and difficult concepts. So here one of the important concept is, if polar of P x1 y1 is passes through another point Q x2 y2, if and only if polar of Q will passes through P. So meaning of this is, for example, this is circle s equal to 0. This is the external point, say x1 y1. So this is the polar of P. So L is the polar of P. What the statement saying that if polar of P passes through a point Q, say x2 y2, automatically the polar of Q will passes through P. Understood? The polar of P passes through Q, then the polar of Q exists. No, for the circle for point Q another polar exists. So that polar should passes through P and vice versa. The polar of P x1 y1 with respect to s equal to 0 is s1 equal to 0 only. S1 means what? x1 plus y1 plus g times of x plus x1 plus f times of y plus y1 plus c equal to 0. This is the polar of P. What is given? This polar is passing through q x2 y2. Given this polar passes through q x2 y2. Okay, means what happened? This is a point on this straight line, means this straight line should this point should satisfy this algebraic condition. So that is x2 x1 plus y2 y1 plus g times of x2 plus x1 plus f times of y2 plus y1 plus c equal to 0. Okay, the polar of P passes through Q, then you will get this result. This can be rewritten as x1 x2 plus y1 y2, because x2 into x1 is same as x1 into x2, no, that is not a big problem, plus g times of x1 plus x2 plus f times of y1 plus y2 plus c equal to 0. So this is an important result for us. Okay, standard notation. In notations, this is nothing but S12. This LHS part of equality is S12. So now S12 equal to 0. What happened, Nana? The polar of P passes through Q x2 y2. We got the result S1 equal to 2. So if and only if you know, that means the polar of Q passes through P, then again you want to show that S12 equal to 0 only. Okay, that's why I want to find polar of Q first. If the polar of Q passes through this, then this result happens. So the equation of polar of Q x2 y2 is again S1 equal to 0 only. Here x1 y1 means x2 y2. X2 plus y2 plus g times of x plus x2 plus f times of y plus y2 plus c equal to 0. This is the equation of polar of Q. Okay students, see this from equation 1, observe equation 1, what 1 saying that. So this is the equation of polar of q. Equation 1 saying that on this line x1 comma y1 is there. Observe, this is a straight line. Put x1 comma y1, put the point x1 comma y1 on this straight line, then you will get same result. Equation 1 you will get. Means what? By using equation 1, we can conclude that x1 comma y1 is a point on this. Okay. From 1, we can say x1 y1 is a point on 2. I am saying this is equation number 2. This result, this equation on 2. That is x1 x2 plus y1 y2 plus g times of x1 plus x2 plus f times of y1 plus y2 plus c equal to 0. So that is this polar, that is 2, passes through P, bracket x1 y1. You can say implies this polar means this, that is 2, equation 2, passes through P x1 y1. So what this giving, this is also nothing but s1 equal to 0 only. Finally, polar of P passes through Q, automatically polar of Q passes through P. Just okay students, just now you observed that if polar of P x1 y1 passes through Q x2 y2, then the polar of Q will passes through P. Such situation, the points P and Q are called conjugate points. Now definition of conjugate points. 2 points A and B are called conjugate points. Polar of A passes through B and polar of B will passes through A. Such situation, A and B are called conjugate points. One important note, if A and B are conjugate points, then their polars are called conjugate lines. Polar of A passes through B, polar of B passes through A. Those two lines are conjugate lines. Conjugate points and conjugate lines. Okay. Now I want to write the definition of conjugate and conjugate points and conjugate lines. Okay students, here the definition of conjugate points. 2 points A and B are called conjugate points if the polar of A passes through B and polar of B passes through A. Okay. So just now I proved, no, if A x1 y1 B x2 y2 are conjugate points with respect to the circle S equal 0, then you got the condition S12 equal 0 only, no? S12 stand for x1 x2 plus y1 y2 plus g times of x1 plus x2 plus f times of y1 plus y2 plus equal 0 only. That's why if these 2 points are conjugate points, then this happens. So this is important for us. S12 equal to 0. So you can treat this is the condition for point A and B becomes the conjugate points. Next, conjugate lines. If A and B are conjugate points, then their polars are called conjugate lines. Okay students, here we have 3 example problems. First problem, prove that 4 comma minus 2 and 3 comma minus 6 are conjugate points with respect to x square plus y square minus 24 equal to 0. It is enough to prove that these 2 points satisfied by the condition S12 equal to 0. Or find the equation of the polar of 4 comma minus 2 with respect to the circle. We will get one straight line. If the straight line passes through 3 comma minus 6, then you can say that those 2 points are conjugate points. That is the one method. Second method is just we can use the rule S12 equal to 0. So I want to use S12 equal to 0 only. So S12 means what, Nana? x1 x2 plus y1 y2 plus of x plus x1 plus x2 plus f times of y1 plus y2 plus c equal 0. This is S12. Now this is taken as now x1 y1, this is taken as x2 y2. X1 means 4 to the 12. Yeah, y1 went into 6 to the 12 minus of x plus 12. Okay, plus g not there here, 0 into something plus 0 into something, c means minus 24. So 24 minus 24 equal to 0. Means S12 equal to 0. Therefore, given points are conjugate points. So similarly, you can solve problem number 2 also. Given these two are conjugate points with respect to this circle, we want to find k value. Same, I am finding S12. Again, I don't want to write the formula, already is there here. So 4 2s are 8 plus 3k plus 0 into something, because x square plus y square equal minus 17 equal to 0 is a circular equation. G and f are not there. Plus 0 and something. Yeah, minus 17 equal to 0. Or 3k minus 9 equal to 0. Okay, 3k equal to 9 or k equal to 3. Therefore, the required k value is 3. Okay, students, third problem, show that these two lines are conjugate lines. First one is try to find the pole of this line with respect to the circle. If the pole is lie on this right line, you can say that these two are conjugate. Or find the pole of this line. So that pole is satisfied by this equation, then you can say that these two lines are conjugate. But which line is best? I want to take this is the line, no? Because here 2, 3, 11, 2 minus 2, 1. So better coefficients. So first of all, I want to find the pole of this line with respect to this. Okay. Yeah, what should write down here? First of all, line 2x minus 2y minus 1 equal 0. L stand for 2, M stand for minus 2, and N stand for minus 1. Lx plus My plus N equal 0 form. Next, circular equation. What is the circular equation here? X square plus y square plus 4x plus 6y plus 12 equal to 0. G stand for 2. F stands for 3. R I want R. C also you want, okay. C stand for 12. So R I want R root over 4 plus 9 minus 12 equal to 1. R equal to 1. Now by using the formula, I want to find the pole of this line. Okay, formula. So x1 plus g by L equal to y1 plus f by m equal to r square by gl plus fm minus n. So x1 as it is, g stand for here what nana 2, L stand for 2 equal to y1, f stand for 3, m stand for minus 2 equal to r square, r means 1, gl, 2 2s are 4, 3 2s are minus 6. Yeah, actually formula minus n, 1 is there, minus half 1 is plus 1, 4 1, this is totally minus 1. So x1 plus 2 by 2 equal to y1 plus 3 by minus 2 equal to minus 1. Okay, students, now first x1 plus 2 equal to minus 2 and y1 plus 3 equal to 2. So x1 equal to minus 4, y1 equal to minus 1. So what happened, Anna? X1 comma y1 means this is the pole of this line equal to minus 4 comma minus 1. Now you want to check second line will satisfy that point or not. So 2x plus 3y plus 11 is taken expression. If this expression satisfies this point, means if after substituting minus 4 instead of x and instead of y minus 1, if you will get 0, then you can say that minus 4 comma minus 1 is a point on this line. After that you can conclude that the given lines are conjugate lines, otherwise they are not conjugate to each other. So 2 into minus 4 plus 3 into minus 1 plus 11, this is minus 8 minus 3 plus 11, minus 11 plus 11 equal to 0. Therefore, conclusion, therefore lines 2x plus 3y plus 11 equal to 0 and 2x minus 2y minus 1 equal to 0 are conjugate lines. Students, one important note here. Yeah, if the lines L1x plus M1y plus N1 equal to 0, L2x plus M2y plus N2 equal to 0 are two conjugate lines with respect to basic circle, then this is the condition. R square times of L1 L2 plus M1 M2 equal to N1 N2. Okay. For the general circle, for x square plus y square plus 2gx plus 2fi plus c equal to 0, then the condition is r square times of L1 L2 plus M1 M2, same. This portion is same. r square of L1 L2 plus M1 M2 equal to L1G plus M1F minus N1 into L2G plus M2F minus N2. So this is the condition for these two lines becomes conjugate lines for general circle, for basic circle. My advice is to no need to remember all these formulae. Without using formula you can solve the problems. Already we did one problem. Okay, you want you can remember. Your wish, you want you can remember. If ax plus by plus c equal 0 is the polar of 1 comma 1 with respect to this circle, and a comma b comma c are prime to one another, then find the value of a square plus b square plus c square. Just first of all I want to find polar of 1 comma 1 with respect to this. Okay, polar of 1 comma 1 with respect to x square plus y square minus 2x plus 2y plus 1 equal to 0. That is s1 equal to 0 only. x1 plus y1 minus of x plus x1 plus y plus y1 plus 1 equal to 0. X plus y, x1 y1 is 1 comma 1, no? Yeah, minus x plus 1 plus y plus 1 plus 1 equal to 0, or x plus y minus x minus 1 plus y plus 1 plus 1 equal to 0. So what happened, Anna? 2y plus 1 equal to 0. This is the equation of the polar. So this is 1. Given actually this is the polar, means these two are identical lines. Understood? So given polar is ax plus by plus c equal to 0, means 1 and 2 are identical lines, means a by 0 equal to b by 2 equal to c by 1. So let it be k. Let a by 0 equal to b by 2 equal to c by 1 equal to k, then a equal to 0, b equal to 2, 2k, c equal to k. Okay, what is given here? GCD of a comma b comma c is 1, means b and c are also co-primes. Here 2k, k means k should be 1. So now I can take the values of a as 0, b as 2, c equal to 1. Understood? No? 2k and k. Okay, given that b and a, b prime to one another, automatically b and c are also prime to one another. So b and c are prime to one another. That's why this is 2 means that is equal to 1 only. So now what do you want? A square plus b square plus c square value, 0 square 0 plus b square 4 plus c square 1, so 5. This is the value of a square plus b square plus c square.